see that? Right, so the main thing in this talk is I'm speaking to sysadmins. Are there any sysadmins in the audience? Yes, I am with you. It's mainly Go from a toolsmithing point of view and deploying Go applications, right? So Go is really picking up steam. So if you're not necessarily writing tools in Go, you're probably going to be faced with the challenge of how do you administrate Go, right? And to me, it's much simpler than administrating a Java application. I've witnessed many of sysadmins quit on the spot when new Java apps roll out. And for me, I played the role of a developer and a sysadmin, but whenever I adopt a new piece of technology, I always need a project to actually try that on. And I play with a little bit of toy applications, but that really doesn't prove much for me. So I actually tried out a configuration management tool called Ansible. Funny, I used to work at Puppet, but it was okay. I got blessing. And on the mailing list, Michael DeHaan, the founder of Ansible, he put out this challenge. And he was looking for anyone that knew Go that could help get Ansible support in a tool called Packer. So Packer is a very popular tool written in Go that lets you manage VMware and Amazon images. But as you're building these images, you can use a provisioner. So some of the provisioners that are shipped what's out of the box are a Bash provisioner or a Puppet provisioner. And Ansible was one of the configuration management tools left out in the cold. So with any challenge, there's always has to be an award, right? So why would I do this other than moving that project forward? And this is what he had to say, that it's small compensation, but if anyone gets the patch accepted, we'll send you a T-shirt and some stickers and build a statue of you in our formal gardens. Well, I have plenty of stickers and T-shirts, so that was no interest to me. But there was an asterisk around this whole formal gardens thing. And I could guess, they don't have a formal gardens yet, but when they do, this is that IPO hope. We'll do it in bronze, and yes, maybe you'd ride in a horse. And I'm like, I could totally see myself on a horse. But in all seriousness, when I'm talking to sysadmins about this Go thing, and you read the documentation, which is great, but it's scary to a sysadmin, right? We come from a world of Bash where we just create these utilities and they do things, and they're like throwaway scripts. And we don't write documentation, and if you're really hardcore, you write a man page. And your friend's like, wow, when did you find time to write a man page, man? Production's been down all day. So you start small. And I remember reading the Go documentation for the first time. I remember a couple years ago, I learned C just to kind of feel the vibes of old school and kind of have that rite of passage. And when I went to go look at the documentation for Go, it was really amazing how simple things were represented. I learned Java once on a weekend, and then I quit the job the following week because it's just so complicated. And I was just like, why would I actually want to do this? But in the Go world, this looked very inviting. So I was like, one thing that I do to test out a new platform is to see how easy it is for me to grab user information and turn it into JSON. That tells me pretty quick I might have to go find a bunch of third-party libraries for the things I actually want to do. So in this case, it actually turned out to be really, really, really simple. And in this case, using just a standard library, I was able to write this. And one thing that was awesome, that it actually ran on my Mac and on Linux. And I thought that was actually beautiful. So once you move past the toy applications and examples, so for me, like internet, any other internet science, that was enough to validate the language for me. And then I moved on to solving real problems. And one of the problems that I had was, it's not really a problem, I really enjoyed this new operating system from CoreOS. Has anyone used CoreOS before? If you haven't, you should totally do it, because I think they did a lot to spread the goodness of Go to a lot of people that weren't paying attention. Tools like etcd are written in Go. A lot of the systemd work they have done in Go. And it really exposed to people how to build system tools that you can actually use for real. So when you download their distribution, they shipped Docker before it was cool. So if you wanted all the latest and greatest bits, you could use CoreOS. And one thing I like to do is build small little clusters on my laptop. It makes me feel really powerful. And when I build these clusters, one thing I don't want to do is like install Linux distros to the disk. So I kind of like to do things with Pixie. And one thing I really do like is iPixie, right? I don't have a DHCP server that I keep running on my laptop. And if I do want to muck with the VMware one, then everything breaks and my system doesn't reboot. So iPixie to the rescue. But when I read the instructions about iPixie, the suggestion here is that I take this Pixie boot script and host it on pasty.org. I don't know about you, but that totally won't fly in production. So the servers won't boot. Yeah, pasty.org is down. Like, what the hell? You can't explain that. Like, that's totally get fired activity. Like, you know, I understand why you fired me. Like, totally, don't tell anyone. But this is where Go comes in. And if you're using Bash, and I know people that actually try to solve these type of problems with Bash, and that's just crazy. But what Go does is, if we outline the problems that we want, all I really want to do in this case, I want to dynamically generate an iPXE boot script based on what we saw here. So this is the PXE boot script that I need, and it contains some helpful things like the SSH key that I want to use, and some kernel and some CoreOS versions that I want to get to. And the next requirement is that I need to serve static content. So what happens in iPXE is the server comes up, it hits an HTTP endpoint, and it gets a boot script. And that boot script should tell it where to go to get its kernel and NRD image. And another thing is, obvious case, I want it to run on my own hardware. And this is perfect, right? So when you think about this challenge in a lot of languages, it gets real magical, right? Like in Ruby, it gets magical. You have to bring in Nginx and unicorns just to make this thing scale. And that's something I really wanted to avoid. So trying this in Go, and one thing that I've really been impressed with is how much I can stay in the standard library to solve most of my problems. I have no knock against third-party tools, but those dependencies actually have a cost. They're not free, right? Someone takes their thing off of GitHub, and then you're explaining to people why the app won't build. That won't work. So for me is we start off really quick. So we start in our package main, and then we import a few things that we're going to use in our library. And then we get down to this interesting bit where I just want to hold some simple configuration. So I don't need to jump into a big object. I think a simple map would do. I just really care about an SSH key and a base URL for the callback for my images. And then I basically take everything we saw in the previous example, and I just stick it in a big Go template. Right? So Go has a nice templating language built in, and I can just use it. And then our next step, edible slides, I like it. Our next step is to actually, I like building 12-factor applications. And if you haven't read the 12-factor manifesto, you should. One thing I like about it is the way you handle configuration, not spreading your configuration over a bunch of files, and in the Java world, XML, then your sysadmins won't quit. Environment variables make it really easy to localize that deployment. So if you're running on your laptop, you set an environment variable, you can deploy the thing. Docker's really hot, and environment variables work really well there. You can also scale this out to a pass and not have to worry about it. And the next thing I do is I do want to kind of specify my own SSH key. So you start adding a little bit of features here. So in this case, you basically supply a file that just stores the SSH key, right? That's really straightforward, nothing exciting there. And one thing that's different for some people is like, wow, look at all those if, error, nil things. I actually enjoy it. Mainly because so many people write code that just ignore errors, and you just get this fantastic surprise, like stack trace is a feature. I'm like, dude, you're filling up all the logs, man, with stack traces. Stop it. So handling the errors at the call site is a fantastic thing, especially when I'm reading other people's code. And it's just a way of communicating that something needs to be fixed there or be handled. And then I'm using this simple map structure, so you don't have to get all complicated. You see struts and types, but we haven't even used those terms yet. We can just stick with the simple maps that we see in languages like Ruby or Python. And here I'm doing a little bit of helper here. I'm trimming some space off the SSH key because I spent hours trying to figure out why things wouldn't boot when there's extra spaces in it. And then here I'm compiling the template up front. I'm saying that this thing must compile or crash. And that way I don't have to do this every time I get a call in. And then we move on to the actual meat of the iPXE server. And it's really, really simple. I think I have an extra line in there where I'm just helping myself figure out what server is contacting my boot server to receive a boot script. So our iPXE boot server, and I love this interface in Go, right? I can still think in my procedural mind that I love and enjoy and just really describe what I want to do, and then the interface will just take care of itself. I just conform, right? And here all I'm doing is executing that template with the environment that we get on boot up. And once we have that, if that blows up, I just send an error back 500 and things stop. And then down here in main, we just glue it all together. And here's some really other exciting features that I like about Go. Mainly the handle func there is, I can just take that function that I wrote and I know it does the right thing, and then it's registered at an endpoint that can be called later. So here's /boot. So if any node wants to boot off of my iPXE server, they make sure HTTP call /boot, and I'll serve them that template up. And the next thing is the built-in file server. So this is really awesome. A lot of times you have to go run and find something like Apache or Nginx to serve your static files. But here it's built in, and I can just use it right from the standard library. And then here I'm just simply printing some simple, hey, the actual app is starting. Kind of gives people a hint that things are actually working. And really simple, I'm just binding to all the IPs available on port 9000. And one thing that's hidden here, though, is the hidden concurrency. So most of the sysadmins I talk to is like, well, I have no need for concurrency. And the truth is you probably do, but you probably don't have time to learn all the tricks and downsides to it. But what's really nice here is that there's hidden concurrency in that previous slide. So even though we haven't specified that we want to handle each of these requests concurrently, it's actually happening behind the scenes. So I extracted this out of the standard library, removed some error handling so it'll fit on one slide. But if you notice, everything that comes in, we get this Go routine that forks off into the background for us to handle that request. This is awesome, so I don't even have to think about it. It's just there for me. So you don't have to worry about if this thing actually takes off and you go from 10 servers to 10,000. You don't have to go and rewrite the app, right? So as a sysadmin, you start building like these production quality things and tools that people won't look down on. It's like, the admins wrote it. Of course they're going to have to rewrite it, right? That goes away. So one thing we can do, and see if this works, and this is just the challenge of live demos. We'll run it. Whose idea was it to have these executable slides? Rob, thank you. That is just fantastic. I actually wrapped some bash and it broke things, but that was my fault, but this is awesome. So now we actually have the Pixie server running live from my presentation. And I don't know if that's good or bad, but we'll roll with it. And so now I have one of my VM instances, so uniquely named Core 0 and Core 1. They're my pet names. And you might not see what I'm typing here, but I'm going to interrupt the boot process to have this grab a DHCP address from my little local VMware stack. Yes, I approved all the things. And now what I'm going to do is attempt to try to get this server to boot off of my presentation. So we'll call chain HTTP : and then let's see if I remember this IP address. If so, I'm going to give myself a high five. Look at that. It actually is working. And we can prove that it works by looking at the slide and actually seeing the log output show up. So we know that the VM actually booted, received this config, and ran through the process. And one other thing I like about CoreOS, it boots fantastically fast. Like, just makes me do it twice. Like, ooh, it's still fast. And then I go around and I show all my friends how fast it boots, and they're like, well, I bet you can't log in. It's like, yeah, I can. So boom, I'm like logged in. And they're just like, woo, ASCII art. So that's pretty awesome. So now I have this iPixie boot problem, and we just solved a real problem, right? We didn't get into the weeds of all the magic that you can do with Go, and it's not really magic. It's all very obvious, but you can actually start small. So a lot of people have been putting Go off because they think they don't have a big problem to solve. But solving these type of problems with Go, I think, is a perfect fit. And it allows you to actually level up and scale, right? So the next thing that we look at is the static binary, right? This, to me, is like the sysadmin dream come true. Like, I don't care about your JVM version. What is all this XML doing? And my computer's getting hot now as I build this thing. So now I can ask for a static binary, and this is awesome. And it's not 100% out of the box, but it's very close to out of the box. So if you download the binary distribution online, you basically go into where you install your Go, and usually the Go root, and you basically build a runtime and a static library for any other target that you want to support. And once you do that, you can simply, there's all kind of build tools out there, and I was really impressed by them. But then I just read the documentation. I suggest you do that. All I had to do was export an environment variable and just call the go build command. So I deleted all those extra tools. All right, so now let's do that and see if that actually works. And you notice that we're not calling out to like uniquely named tools like rake and make and npm and the things that require the internet to actually work. You can actually just build these things with the things that are built in. So I don't have to go and learn another set of tools to get started and actually make progress. So let's go into our directory where my iPixie server is. And there's my main.go. And to build this thing, right, we just do go build dot. And that's it. Like, the thing is done, all of it. And we look at it, that's all of my dependencies, the Go runtime, all bundled in one package. And some people look at it and say, "But look at it, it's like 7.6 megs." I'm like, dude, it's okay. We're not running these servers on a zip drive. We have plenty of space, I promise you. That is not the problem. So by default, it's going to compile things for my particular distribution, right? So if you do go env, it'll tell you what that is. There's so many magic things in Go that are listed, like what are my dependencies, Go JSON, and it figures those things out and bundles the right things into the right place. But once we have that, we can also easily, quickly cross-compile for other targets. We talked about that. So one target that I want to cross-compile for, and luckily I don't have to work on, but we can cross-compile for Windows. And we get this wonderful, and you know it's Windows, right? When you see the exe, you're like, yes, Windows. And yeah, and what you can do, and I've done it before, where I built a small utility trying to bail out some Windows admins, and I compiled that and put it in HipChat, and they got it and said, what do I do with that? I was like, just run it. And it ran, and they were like, magic. No MSI installer, no progress bar. I think they were let down by the lack of progress bar, right? That lets you know it's working. So no progress bar. Go doesn't have that feature, but you don't need it, right? You just drop it over there. And what we want to do now, so you can imagine how simple deployments can be with this tooling. So now what I'm going to do is, naturally, we're on Mac now, and CoreOS is a Linux distribution. Let's see what it takes to get this to run on CoreOS. We're going to try to get meta. Can CoreOS Pixie boot CoreOS? And this should be obvious it could. But let's see if we can make it work. So we're going to set this to Linux here, and we'll do go build again. And let's verify that we get a Linux binary. Yes, we do. This is like magic when you do it to people for the first time. Like, wow, you can just do that for different machines? Like, yes. All right, so let's talk about deployment really quick. So once we have these static binaries, and it was mentioned earlier, all you have to do is really SCP the thing to the target that you built it for. So in this case, we can just push this out to our CoreOS machine. And in this case, what you're seeing here is me dropping this binary into the bin directory of my CoreOS user. And then systemd is like all the hotness, whether you like it or not. It's going systemd. Systemd, woo! All right, so, but systemd is the thing, and CoreOS ships with systemd out of the box. And it's really nice because I was able to get ahead of the curve on that. And the nice thing about systemd, especially when you have these simple binaries, your systemd configs look really, really simple. Right here, I do a little bit of documentation, letting people know what this is. This is a CoreOS iPixie server, and where they can go find more documentation. But the only two lines that I really care about are setting this environment variable so that we know what our callback URL will be, and just the path to the executable. And we're done. You notice we're not connecting to the internet, hogging all our bandwidth, and hoping and praying that NPM is actually up when we do the deployment. We don't have to do that, right? It's all self-contained. Once we get everything on the other side, we can call systemd to start the iPixie server. In our case, it's not as simple as just moving one binary because we have a couple of kernel images that we need to get to the other side. So I did write a little script to kind of automate that process. But we will copy over all the things that we need, including the binary. So we'll just come up a layer, and we'll just use my trusty dusty bash sync. Ooh, we need to know what host. And that was 177, I believe. So now we're syncing all of the dependency, mainly the CoreOS images. We're pushing our binary over, and we put the service file in the right place for systemd to grab it. So once we do that, I can just jump on the CoreOS server, and we'll try this. System control start iPixie server. And you're like me, it's like, where did the logs go? And I figured it out one day. It's like journal control. I don't know why they thought that was awesome, but it's not. But we have it. It'll work. And then we can do -F to tell it. So we actually now have that binary you just built on my Mac running on CoreOS. And according to this output, it's actually ready to Pixie another machine. Now, I did this once, prep for the talks. I don't know if it's going to work again, but we'll try it. So this CoreOS image, we're going to attempt to boot it from the other CoreOS machine that's running. So we'll start it, and we'll go through the same process. We're going to interrupt the boot process. I'm going to tell it to DHCP, so it's on the same network. I'm going to give it permission. And then now I'm going to have it chain its boot process to pull the binary from this other guy. So 12, and that was 177. And then we'll do port 9000. And then we'll do boot, and then we'll cross our fingers. I hope it works. And it's working. Thank you, demo gods. And it's booting, and we can see that it's booting because we get the nice output right here on CoreOS. So it's really simple to do, really straightforward, and it's already booted. And for those that ask me to prove it by logging into it, I surely will. Boom, and we've logged into the other CoreOS box, so now we have like a cluster. And I'm one more CoreOS instance away from being like Google scale. I can feel it. So during the hack day, if you need compute power, come see me. And before we show that, to wrap things up, most people get really, really excited. I show people the fire, and then they want to go burn down everything. So you got to slow your roll. Go read the docs. They're really good docs. They're really straightforward. I'm actually impressed by how much non-poetry they tried to write. They got straight to the point. Here's the spec. Here's what happens. If you do this, this does that. If you do that, that won't work. And it's easy to get started. So once you do it, you'll have Go at your disposal, but you got to contain that excitement. Because if you don't, you may run out and do something like that. And once you do that, it's like Go forever, at least for you. But other than that, it's like it's go time. So you know Go, and you should get to it. That's it. Thank you.